Hello. We will talk a bit today about pyproject.toml, a new invention in the Python world. Not that new, but we will see what's what and how it works and what it is for. I'm Piotr, aka Gunblade. I'm from Cracow. I don't like speaking about myself, so let's carry on. Pyproject.toml, what it is? Quick introduction first. It defines dependencies to build your package, like setup tools, wheels, etc. Any package that has to be installed, not as your package dependency, but to build your package itself. Any compilers, etc., etc. It also specifies what tool should be invoked to use with. It can contain some configuration for your project tools like some Flake 8, actually not Flake 8, but some other linters, testing, etc. It also contains the project metadata, can contain the project metadata, so what your package is, etc. And maybe some other things in the future, we'll see. So let's first go back in time to the times where there was nothing. At the beginning of the Python, if you wanted to release your package, you had to create installer of your own, or just tell your users how to install it, etc. You will distribute it on your own. So setup.py and dist-utils was created to mitigate that problem somehow. It was introduced in Python 1.6, so pretty early, in 2000. It basically uses executable file of setup.py, and inside of it, which we'll see later on, is just some basic import and code one function. That's all you need. It offers the way to build your package, and it just works. This is pretty much, holy shit, that's big. This is pretty much the code you need to distribute your package with these details. At least at first, that was the code that worked in Python 1.6. Yes, I looked back in the repository to find an example that worked, and it works. And that's it. You specify your name of your package, version, maybe some other things, however you want. I think there was absolutely no validation of what you will specify here at first. You can just add anything. Only name, version, and PyModules were required. And after that, you can just run Python setup.py as this to package your package, so to build an archive that just contains all your project, especially it contains the setup.py file and modules mentioned in the PyModules. Then you can install. You don't have to have the sdist first built. You can just install. It will install the package to your system interpreter, and you can also build some binary distribution, the exe file for Windows, RPM or dev files for Linux distributions. Then someone decided that it will be a good idea to specify what can be done here, what is required, and what can be specified. So the package's metadata was established in separate pack and later updated, and support of it was added to these utils. That was pretty much it. Then PyPI came to life, so way to distribute your packages. But at first, it was only the index that you can browse, etc. After a while, the easy install was introduced, so you can automatically install everything that is hosted in PyPI. And let's pause here, because there are some problems. First of all, no way to distribute compiled build packages. That means you have to, I mean, outside of the system-specific things like the RPMs, execs, and deps, there was no universal way to do that. So you couldn't just install package. You have your easy install had to download it, build it on your computer, and then install it. Second one, features to these utils, any new things, features, bug fixes, etc., had to go through the standard change, through the changes to the standard lib of the Python, because it was in the standard lib. So it comes with the third problem. If anything was updated in the these utils and you had to use it, you have to switch and especially convince your users of your package to switch to the new version so that these utils will work for them. And there was a lot of things that these utils just cannot do. And if you want to do something outside of that, you have to hack your ways and etc. No plugin systems, no easy way to do absolutely anything. Setup tools. The end was the setup tools. Setup tools was introduced after that. It wasn't kept in the standard library. That was the first benefit. It had the fast development because you don't have to put everything in the standard library and then update the whole Python with it to have new features. There was a lot of things supported, like different compilers, etc. Building X. It was great. It had some plugin system, so you can just tweak it around a lot of more of configuration. And it was a thin wrapper around these utils, basically. It actually still is a thin wrapper around these utils. As you can see, only 25,000 lines of code, very thin wrapper. All you need to do to use setup tools in your project is replace this import from previous with the import from setup tools, and convince your users to install setup tools on their machines. Wait, hold up. You have to convince somebody to install another thing to install the thing that he requires. What about now? How we can solve that problem? First, eggs. As I mentioned here, there was some binary pre-built packages called eggs. Eggs had some problems. First of all, they didn't. The binary distribution of anything that was written in C, not directly in Python, had to be compiled for each platform separately. That means you have dozens of eggs for one package, and the installer has to choose, easy install in that case, had to choose which eggs to install actually. That was troublesome, especially that not every package, not every platform could be supported. On top of that, easy install didn't support eggs at first. It came later on. So eggs were only usable when you downloaded them directly and installed them on your own without the package manager of any sort. And eggs were eggs, and eggs just sucks. Everybody agreed on that in Python world that they have to disappear. Next solution, bring setup tools to stdlib. Well, then you will have all the problems of these modules. Slow development, slow introduction of changes, and everybody has to update the whole Python to use the new build tools. So maybe we can do better. Maybe pip to the rescue. Not only pip, but also some Linux distributions, because pip was the replacement of the easy install, so you can somehow count that people will use it to install your package. And pip was built using setup tools. That means setup tools were one of the requirements to install pip. That means you have setup tools in your system. Yay. Linux distributions also started to ship their Linux package with setup tools pre-installed, and you can upgrade it independently of the Python itself. It sort of worked, but worked. Also, wheels. Not long after creating pip, wheels were created. Wheels were much better than X. There was still that limitation that you have to compile every package to all the systems you want to run it if it has any C code inside or anything that you have to compile. But there were much better working with pip and than X, and pip supported them almost out of the box. We still have some problems. First, setup tools needed to be backwards compatible all the way down. That means if I will install new setup tools, it has to build packages that were pushed to the PyPI repository 5 years ago. Second, if you need specific version of setup tools because, I don't know, your package won't build in the too old setup tools, well, you have to assume that people will update setup tools all the time, which wasn't the case. And what if I need a specific plugin to the setup tools? Yes, setup tools had some way of installing plugins. It was a bit hacky, but it worked only for plugins created specifically for setup tools. So if I need anything else, like, I don't know, I need my I don't know, linter. For some reason, I need a linter when building my package, or any compiler that is not just supported by setup tools. I'm out of luck. I have to hack the setup py file. Remember, it was just an executable. So if I import something at the top, it has to be already installed. So I have to install something before importing. There were some hacks like putting some codes at the very top of file that will first find all the requirements, install them, and then rerun the setup py or ask the user to run it again. And last problem, what if I don't want to install all those things that are required to build 5 packages that I need into my environment? After the build is done, they are not needed, but they will be installed anyway just to build my package. So, well, maybe somehow create requirements in the setup py, I don't know, change it a bit, etc. Not really, we cannot, because it's, again, run as a simple Python executable file. You really cannot do it because it's executed directly. You can sort of hack it, but as I mentioned before, it's very nasty. You can use only setup tools plugins that they work, they are hooked inside setup tools. So setup tools know that they have to be installed first and then called. But if something is not a plugin to setup tools or isn't wrapped in a setup tools plugin, you're out of luck. Also, you cannot upgrade setup tools. So, pyproject.toml was born as a solution to all of our problems. What is pyproject.toml? We learned a bit at the beginning, now a bit more in depth. It was introduced in PEP 518, and the same PEP defines that the pyproject.toml has to list all packages for your build that are required for your build process. So anything that installs your package will just pull those packages first. To not clutter your system, it creates for that build process a separate ad hoc virtual env. It installs all the dependencies there, it builds the package there, and then it throws away that virtual env, and there is no clutter in your system. It was extended by PEP 517. Yeah, this PEP came first, because, but it extended this PEP. I don't know how it works, but it works. So you can specify another build tool instead of just calling the setup py. You can call whatever you want there, as long as it confirms to the API defined in that PEP. And extended by PEP 621 to add some metadata into the pyproject.toml, so you don't have to specify that metadata for your specific package builder, like for setup tools it will be, or these two tools it will be in the setup py, but you can directly do it in pyproject.toml, and all package builders eventually will use it instead of their own configuration. And it can contain configuration of your tools, the tools of your choice for the project, and probably many more things in the future. We'll see what future will bring. It looks like this. Basically, you have the requires line, build backend line. In requires you define all your dependencies. In build backend, you set up you define what should be run to build your package. This is actually a default that will be assumed if you don't have a pyproject.toml at all. Also, the build meta legacy means that it will just run the setup py file through the setup tools and execute what is here. It can be just a setup tools again, so setup tools inside a setup tools, yay, but that's basically how the legacy works. There is another builder in setup tools without the legacy part that just omits the setup py file at all, and you can also define the backend path. If you want your builder or plugins to your builder be contained inside your project, you can add folders from your project that contains those files that have to be available in the Python path for the build backend. It can even contain the whole build backend for you. You just extend that backend path. Disclaimer: backend path is not added. Like backend path normally is empty. Like your project is not your project root is not added to the Python path. So if the setup py wanted before something from your repository, in setup py it just works. You could import that from your project. Now you have to explicitly specify that you want to import something by adding it to the Python path, then you can import it. So how it works? No pyproject.toml, just do it old-fashioned. It will just execute in pip. It will just execute your setup py file as in the old ways. If you have the pyproject.toml, but there is no build system at all, there is no entirely this category of settings is omitted, it assumes defaults, so what's here, and it will just execute those defaults. If no build backend, if build system is defined but there is no build backend, it will error out because at this point it doesn't care about the defaults. You have to specify build backend on your own, and otherwise it just executes configuration that is in accurate form. You can force build isolation on or off with some parameters. I will explain it here. So no build isolation will just disable the build isolation. That means the package will be built outside of the ad hoc virtual env won't be created, and the package will be built inside your current environment. It can be system or virtual event or user environment, anything. That means that requires won't work at all. Pip don't care about that, will not install anything that is mentioned here because he doesn't want to clutter your current environment. You can use no use step 517. That means pip will install, except you specify that, will install your requirements, but then instead of running the build backend specified pyproject.toml, it will just run setup py. You can also use PEP 517 to force building build backend. It actually only makes sense if you don't have the pyproject.toml at all, but you still want to use those default settings, so you don't want to execute the setup py directly for some reason, maybe to test if your package will work with those defaults. But there is no way for me as a package maintainer to disable the build isolation. If the pyproject.toml exists, but I, for some reason, am not supporting those things like requirements, etc. They are not, the defaults are not working for my project. I cannot globally disable that. If you want to use my package, you have to add the no build isolation on your own. If you know any circumstance when this cannot be fixed but just configured properly by pyproject.toml, for example, I've heard some Magic OS packages have to be installed system-wide, cannot be installed in virtualenv, and they are sometimes dependent, a dependency of the package builder. You cannot do the build isolation at all. If you know any circumstance, please speak up. I cannot provide such details about the macOS things because, first of all, I'm not using macOS. Second of all, I don't know even what package to look for. But I just heard somewhere that it happens. If you know any details about that, please speak up. Please speak to the pip maintainers. Maybe just speak directly to me. I will proxy that. Because at some point, pip will make the build isolation mandatory for every single package. There will be no simple setup py execution outside of the ad hoc environment. So it will just break, and there will be no way to install those packages using pip anymore. So those are some, at least of some build tools that support pyproject.toml. Let me rephrase that. How build tools are supporting pyproject.toml, because not all of them do. These utils are deprecated right now. That means there will be gone. The code of these utils was moved to setup tools. It will no longer exist. In Python 3.12, it will be removed from the standard library. So you don't have really to move to setup tools, because if you install setup tools, it will install its own copy of these utils, because once again, it's still a thin wrapper around these utils with 50,000 lines of code. It's very thin. So these utils will be gone. Setup tools. Setup tools has two ways of operation. As I said before, you can use the legacy or without legacy. First one will just call setup py. Second one will not use setup py. So you have to use setup CFG to provide all configuration for the setup tools. This is somehow handy because you can be sure that nothing from your code, from your package code is executed ever when building it. Because there is not even setup py to execute them there. Unfortunately, setup tools is not yet using PEP 621, which allows you to configure your package metadata through the pyproject.toml itself. You have to configure it via setup py and use legacy, or via setup CFG and use either of those, because calling setup py will also get those configurations from setup CFG. And then Poetry, which you may or may not know. It's a package building tool, but it also can manage requirements for your project that is not a package. So it's very universal and very nice. It works out of the box with pyproject.toml. You just specify. I didn't paste it here. You can find it in documentation. Actually, running Poetry new will create setup pyproject.toml with correct configuration. So I didn't paste it here, but it was created after the pyproject.toml existed, and it was created for the pyproject.toml. It also doesn't have the PEP 6.1, but at least it's configured by their own configuration from inside the pyproject.toml. So we have only one configuration file, and then Fleet, which supports PEP 61, supports pyproject.toml. It's like everything that has already a defined PEP and released PEP is supported by Fleet. Even so, beta, like unreleased PEPs are already implemented in Fleet because it's somehow somewhat a showcase of what pyproject.toml can do. So it's very nice. And then Conda. For Conda, it's completely not applicable to support pyproject.toml because Conda works outside of Python. It doesn't only install Python packages. It can install any binary, any package, however, whatever you want. So running in with the use of pyproject.toml doesn't make sense at all. Tools, yes?
What exactly is Fleet? Is it something new? And what purpose does it serve actually?
Fleet is just a package builder, like setup tools, like these utils, etc. But it cannot, as far as I'm aware, it cannot run right now compile C extensions. It just knows how to package things and how to use pyproject.toml to do all the things. And as I said, it was a package building tool created only to showcase pyproject.toml, but you can use it on production. It is very lightweight. It has much less stuff than Poetry or setup tools. But if it fits you, then sure, go for it. Any other questions? Okay, so continue. I'm continuing. Other tools that support configuring them through pyproject.toml, pytest, blacktox, autopep, etc. with one simple thing. Black cannot be configured outside of pyproject.toml at all. You can specify arguments to the command line, but if you don't have pyproject.toml, you have to specify those arguments each time you run black. You cannot configure it outside, which if you connect it with the thing that I mentioned here, that if pyproject exists, but there is no build system, it defaults to executing inside building package inside the temporary environment. So if you want to configure that, if you want to configure black and you create pyproject.toml, then you are opting into that feature and there is no opting out. Sorry. You have to specify all your requirements for building the project if defaults doesn't suit you. Otherwise, your package may not install. If that wasn't clear, that's only about packages because you don't have to build your projects through any of those. Do with your projects whatever you want because other people probably don't have to build them on their own, so they don't have to execute any of those, right? So, continuing. Tox, autopep 8, mypy, great. There are some tools that are incompatible with the pyproject.toml configuration. They either are in the state where they are deciding how to approach it, because for example, Flake 8 configures can configure from with .flake8, with setup CFG, with tox.ini, And I think there is one more configuration, so it will be the fifth type, file type that they will have to support. So they're trying to decide to drop some of the old configuration files in the process. But there is also a roadblock for flag 8 that they say if the opting in to the automatically opting into the build isolation for the with the creation with pure existence of the pyproject.toml won't be resolved. They are not supporting pyproject.toml for the configuration because they don't want to force their users to use that process. BAM version, glint, pycode style, all of other, you can see the awesome PyProject to see detailed list of tools that support and that don't support, reasons why they don't support, some links to the GitHub issues discussing the incoming introduction of pyproject.toml. I very recommend using that link to see if all the tools, or at least most of the tools you're using, will support them, so you can squash all your configuration in the root directory of your package into one single file. And that's it from me. Are there any questions? Yes.
You said that there were eggs before, and then there were wheels.
Yep.
Could you explain to me what exactly was the difference between those? Why do we need wheels if we had eggs already?
Yes, I wasn't really digging into the topic. I wasn't aware of eggs where they were popular, so I decided that it's not. Let's not waste time after they are deprecated. But basically, Python community decided that eggs were awfully designed and they have to die, and wheels came after that to replace eggs, basically. That's all I know. Okay. Any other questions?
I have a question. So, because I didn't catch it, does it mean that, like, in the future we will have to update all our packages?
You didn't cut that one, right?
But basically, we will have to update our packages if they are using setup py to pyproject.toml, right? Because this will be like deprecated and then dropped.
Not really. Defaults will be still here. So those defaults mentioned here will just work with your packages that if you don't have the pyproject.toml. Right now, if you don't have pyproject.toml, it works the old way. After some period of time that pip didn't define really, they will enable using the new way of installing packages and introducing those defaults. Also in the case when you don't have the pyproject.toml. But that means if you are requiring anything outside of that set of requirements, or if you are importing anything from inside your setup py from your project, like project version, for example, yes, it won't work then. You have to specify also the backend path, backend patch to extend the Python path to include also some directories inside your project. So your build backend has access to them when building your project. Like has access to importing things from them. Let's phrase it that way. So if you're doing from your package import version or something like that to put that version inside the setup tools, yes, it will break if you start using pyproject.toml or after the after pip introduces those defaults for all the packages. Anything else? Any questions? Yes.
So pyproject.toml is strictly for stuff that we need to use setup py, right?
Not really. If it kind of replaces, like, it removes the need for the setup py itself. Like, if you if you specify the build backend without that legacy and column part, without that, so only this part will be there. Setup tools will be called directly, and then setup tools won't even look for the setup file.
So in pyproject.toml, then we would have to define stuff like name of the package, I don't know, owners of the package. And is it already possible?
Yes, it is kind of possible. Kind of possible as I explained here. So setup tools doesn't have the, like, it is defined in PEP 6.2.1, but setup tools doesn't use it yet. But you can configure setup tools through the setup CFG. But warning, if you are using the here mentioned setup tools build meta without the legacy, then your setup py will not be loaded at all. So you have to have it inside the setup CFG if you are using setup tools before they will introduce that support.
Okay, so you're just saying that if I would like to have it everything in pyproject.toml, I should wait a little bit more, right?
Or you can switch to Fleet.
Okay. Did you know? Do you know if there will be some coverage of the problem that when you are installing with setup.py and with pip, there are actually two different operations going on?
Kind of, yes. If you will use the legacy backend, it will call the setup py. It will call it, I think, setup tools tries to recreate.
That pip install is calling doing sdist package, and setup.py is doing other one or other way around. So sometimes if you specify things in setup.py that works only for sdist, you will not build bdist. So you will be able to. Right now you are able to, for example, build a package with setup.py, but not with pip install. Do you know that if they have chosen like one or the other? Or...
Actually, I think you can build with pip packages with pip. You can only build wheels, but you cannot build sdists. That was the idea. So you are forced to use wheels somehow, but there is, I think, a package called build tool that will call build process through the pyproject.toml. So if you want to build sdists outside of that, you will need another package for that, but only for like locally your own test purposes, etc. I think setup tools also have some command line options to use that to just execute these those backends directly from setup tools without calling setup py.
In the future with pyproject.toml, this will be solved somehow, or still you will have
basically, the idea is if you are calling the package, like calling the install process manually, you will either use the build/install a backend that is being used inside your pyproject.toml, or you are using another package to call the whole process through.
Okay.
Because like this process is intended to always be used through pip or any other package manager.
Okay.
Anything else?
When you set up the virtual environment where it makes all this setup of TOML, so you're talking about only the wheels and the setup tools, or you're talking about their dependencies as well? Like a prerequisites, like let's assume there are any other libraries dependent.
For the build process itself?
For the package to install.
For the package to install? For the package to work, it's the job of those tools to somehow gather that information and build it inside your package. So There is PEP 621 together with another PEP that was basically the decision of the format of the requirements inside the pyproject.toml, but this introduces also fields inside the pyproject.toml that define your install requirements. But those have to be used by tools if they are, because they can use their own configuration for that right now. And setup tools is using their own configuration for that. Poetry also, but it's inside pyproject.toml, and Fleet is the only one from this list. There are some other ones mentioned in the internet, but they are not popular. But Fleet is the only one from the popular ones that fully supports the metadata from pyproject.toml that defined in PEP 621. Anything else?
So if I understand correctly, if we use build meta and not the legacy part, we will be using setup.cfg and not setup.py, and as a result, there is no chance to execute any arbitrary code during installation.
Yes.
Assuming that all the dependencies also use build meta.
Yes.
And can you enforce that? Like there was this force something flag, does it enforce it for all the dependencies or?
There is no force build isolation, unfortunately, yet in pip, so we cannot force that. But even if the backend defined here can do whatever it wants,
Yeah.
so you can just create malicious backend that will do something like that. You cannot really avoid it. Anything?
I'm not really sure how to phrase my question, but the issue is, not the issue. The thing that I would like to do is that I have a Python project,
Yeah.
which obviously to build requires Python. So maybe putting the requirements into pyproject.toml, well, it looks like a great idea to just put Python there. The question is, can I run this thing without pip, actually? Can I mean, I would like to maybe use it inside my CI machine, which would not install anything on, I would just like to build the thing, create the artifact, and then push it somewhere, instead of installing it with pip. And can I do that?
Okay. First question is Siphon a Python package?
Yeah. You install it with
So you can put it right here. Then, if you want to execute this process, there is, I will just look it up.
For the record, usually you use setup.py to install, to build Siphon packages. You just put, create an extension and place it as the requirements or something like that.
Sorry for the dark theme. I know you cannot see really that. I think it will be here. So, no, that's not it. I know where to look for it. I think it should be there. Packaging. No, there is no other tools. I don't remember the tool exactly, and I cannot find it right now, but basically there is an official tool that you have to install and then run it inside your project to trigger the pyproject.toml pipeline, basically.
Instead of using pip.
Yes. I will look for that after the presentation and we can talk then.
Can you install it with the pyproject.toml requirements, or is it something that you have to pre-install before you install the requirements?
can you really predict the future?
Sorry?
Can you predict the future?
Maybe.
Like, I think your the computer cannot predict that you will run the command and install it before you will run it. It's a command to be run, so like right now you are using pip to install something, you will use something else instead of pip to build that thing. Your package, it means.
Maybe it would make sense to integrate it into.
I think it may be right now integrated somehow, like pip is installed almost everywhere by default. I think this package also will be, or maybe even it is right now installed. Maybe not everywhere, but in a lot of places. I really don't remember how it was called. I know that I found it. Maybe I have it actually in my notes.
We can take it to find.
Okay. I will just look for it.
Otherwise, we can talk about this after the talk.
Any other questions? In the meantime? Nothing? Then I think thank you for coming to my talk. And